change of momentum is directly proportional to force. Come on, recall second law. Conservation of momentum of an isolated system remains constant. Strong nuclear force, weak nuclear force, electromagnetic force, gravitational force. More force, more displacement. Less force, less displacement. Hello students, this is SD Sir again from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. Thought for the day: the most fabulous thing one can have in life is knowledge, and the most evil that one can possess is ignorance. Knowledge will lead you to the path of success, where ignorance will drown you to the epitome of failure. Dear students, let us continue our discussion on the laws of motion. Before we continue today's session, we will recall the three important laws that we have discussed previously, where the first law of motion says that you require an external force to change the position of a body. Any body which is at rest continues to be at rest, and any body which is moving continues to move until an external force changes its position. And we also associate terms like inertia, examples for inertia in that discussion. Second law, very important, which told rate of change of momentum is directly proportional to the applied force and takes place in the direction of the force. If the body moves in the same direction of the force, its momentum increases. Ball instantly struck from the bat of Kohli. And if a body moves in a direction opposite to the applied force, a ball stopped by a goalkeeper, momentum decreases. And finally, the third law of motion, which told for every action there has to be an equal and opposite reaction. And hence, why the net force acting on a system doesn't become zero? Because both action as well as reaction act on two different bodies. Now, continuing my discussion, a very, very typical analysis, something called law of conservation of linear momentum. A very important proof which is asked always for 3 marks in the exam. Law of conservation of momentum. And typically speaking here, linear momentum. Because when you study your rigid body physics, there we study conservation of angular momentum. Today, we are interested in the conservation of linear momentum. Law of conservation of linear momentum. The statement of the law says the total linear momentum, total linear momentum of any isolated system, the total linear momentum of any isolated system remains constant. Yenidu isolated system andre, if there is no interaction, exchange of forces between the system and its surroundings, means it is isolated from the surroundings. First helide prisoners isolated from the society. So the total linear momentum of an isolated system remains constant. Now I have to prove this. And to prove, I will consider 2 colloiding bodies. 2 bodies which colloid each other along a straight line. I will prove the concept of conservation of linear momentum. In case of 2 colloiding bodies, 2 bodies which colloid, which strike each other in a straight line, linear momentum. Now, consider 2 objects of mass MA and MB moving with initial momentum PA and PB. So this is the first body. It has mass MA and initial momentum is PA. P usually denotes momentum, alva. We wrote momentum is the product of mass and velocity. Second body of mass MB, momentum PB. And this is the picture when they colloid each other. So 2 bodies. The first body has mass MA. The second body has mass MB. PA, momentum of the first body. PB, momentum of the second body. Now, we will first consider total initial momentum. Total initial momentum of the two bodies, which is PA plus PB. Total initial momentum of the two bodies, which is PA plus PB. After collision, total final momentum is PA dash plus PB dash. Total initial momentum. When I say initial, I mean before collision, before the two bodies strike. PA plus PB. Total final momentum after collision, PA dash plus PB dash. Now, from Newton's third law, very clearly we say action and reaction are opposite and equal. They are equal in magnitude but act opposite in direction. So if you observe here, how did I write this expression? Very simple. Rate of change of momentum is directly proportional to force. Come on, recall second law. Rate of change of momentum is directly proportional to force. So this is force acting on A due to B. So this is P A dash minus PA divided by T, which is minus PB dash minus PB divided by T. See, very simple to understand. Final momentum of A minus initial momentum of A divided by T means rate of change of momentum of the body A. PB dash minus PB by T. Final momentum of B minus initial momentum of B divided by time, which means rate of change of momentum of B with respect to time. T and T gets cancelled. Now, P A dash, this minus PB dash comes to the left hand side. PA dash plus PB dash equals PA plus PB. Beautiful result. Observe. PA dash plus PB dash, sum of the final momentum of the two bodies equals sum of the initial momentum of the two bodies. They are equal, which means linear momentum of two bodies colliding each other is established. Therefore, I can also say in any isolated system, when two bodies collide each other in a straight line, the sum of their final momentum should always be equal to the sum of their initial momentum. So total linear momentum of an isolated system is always constant. Beautiful result. Yeah, many applications. Walking on the ground, swimming, the Monte Carlo experiment, the pebble draft experiment, all of them are based on this result. Launching of a rocket, I'll come to that next. A few simple numericals. A body of mass 2 kgs moves with an acceleration 20 meter per second square. When a force is applied on it, calculate the force. Mass of the body is 2 kgs. Acceleration is 20. I have to calculate the force. Any rocket science? No. From Newton's second law, F equals ma. Mass is given to be 2 kgs. Acceleration is 20 meter per second square. So force is 40 Newton. Very simple. This the same way. Please refer to the session. I want you all to work it out as an assignment. Now, we will understand the common forces in nature. Right in my chapter 1, I have mentioned the basic forces in nature. But these are the common forces. Which are the 4 basic forces? Strong nuclear force, weak nuclear force, electromagnetic force, gravitational force. Which is the weakest force in nature? Gravitational force. Strongest force? Nuclear force. Now, which are the 4 common forces in nature? Weight, tension, spring force, contact force. 4 common forces: weight, tension, spring force and contact force. Weight, common term. Please to understand, the moment we say weight andre bere enu meaning illa. It is a downward force. Weight is a downward force acting on a body because of the gravitational pull. Here, I would like to make a concept very clear. Most of us mislead and understand mass and weight are 2 same terms. Estapad in weight, 5 kgs. Nonsense. Say mass is always 5 kgs. Now, weight is the downward force with which the body is pulled. It is the downward force acting on a body due to gravity. The difference is mass remains the same throughout, but weight changes from place to place under the influence of gravity, and it is always measured as the product of mass and gravity. So here W is m into g, M is 5, nearly G is 10, 50 Newton downward force. So please do understand, mass and weight, they are not same. They are different entities. Mass is measured in kgs. It is same throughout. Weight is measured in Newton. It is the downward force, downward pull exerted on a body due to gravity. Tension. Tension is the force exerted by a spring, or very specifically string, opposite to the direction of weight, or in simple to understand, it is some force which acts opposite to the direction of weight. Simple pendulum bob, the weight will be acting downwards. String will be pulling the bob in the opposite direction. That is what is called tension. So tension is the force exerted by a string opposite to the direction of weight. Spring force. Now, let us consider example of a spring. I apply some force and I compress the spring. Compress ಮಾಡೋದು, ಹಿಡಿ ತಕೊಳ್ಳೋದು. This is the natural position of the spring. External force is applied, it is compressed. Or again, I apply some external force. Now the spring is extended. First case, on the application of an external force, there is compression. Second case, when an external force is applied, there is extension. Now, if I have to bring the spring back to its normal position, I again require a force called restoring force. Okay? That force is called restoring force. See, beautifully, name itself says, restore the normality. And that restoring force is what you call spring force. It is that spring force which will bring the spring back to its normal position, either from extension or compression. Apply the restoring force. The spring comes back to its original position. That is what is called spring force. And we write, force is directly proportional to displacement. More force, more displacement. Less force, less displacement. The proportionality is removed by the constant K, and this K is called spring constant. And the last one is called contact force. Now, when an object comes in contact with the other object, there is contact between the molecules of the two objects. Because of this contact, an intramolecular force is developed. Force between the molecules of the two surfaces. And this is what is called contact force. So my dear students, in my today's session, evidently I have established the law of conservation of linear momentum in case of two bodies colliding in a straight line. Simple problems we have seen on mass and acceleration, and we have understood the basic forces or the common forces in nature. My next class, we will again continue with interesting topics. Until then, thank you.